guys, this is Mrs. Tran-Bloom again. Welcome back to 4.4 notes. Okay, so today our goal is to finish all of example 1 and all of example 2. Okay, I know the vocabulary video for this section of notes was really long, and thank you to one of my students that made a comment, a not so awesome comment on YouTube. I just want to let you know that your class is 50 minutes, so normally you should be spending about 50 minutes on your homework. I know not everyone needs to spend the same amount of time, and some of you don't need to, okay? I'm sorry, I'm moving things around a little bit. Some of you don't need to, and some of you need to spend more, but the recommendation is about 50 minutes of homework each night. I know I try to give you less, okay, but sometimes it does go over. So I just need you to understand that not all the time that I'm able or the teacher is able to keep it about 30 minutes, okay? But anywho, just to make up for the long video notes on Friday or the prior day, this video is a lot shorter, okay? So here we go. Example number 1. I just want to make sure you guys can see this, okay? It's really blurry. Okay, so I'm going to zoom up. I'm just going to read the direction right now, and then I'll zoom into just problem A. Example 1. Find the vertical, horizontal, and this one should be or oblique asymptotes, if any. Okay, so we're just going to zoom in to problem A. Here we go. All right, problem A says r of x equals 5x squared all over 3 plus x. So we are going to find the vertical asymptote. Can you see with the green pen? Okay. Let's borrow a different colored pen, something that's slightly darker. Okay. So we're going to find the vertical asymptote. We're going to call it VA. Now vertical asymptotes, they are lines. So in order for you to make it into a line, you need a y equals or an x equals. Okay. So we're going to take the denominator, which is 3 plus x equals to 0. The reason we said it equals to 0 because it can never ever be 0. So that this is why it's creating an asymptote. So we're going to solve both sides by subtracting 3. So x equals to negative 3. This is your vertical asymptote. Okay. Now you either have a horizontal or oblique. Okay. Sometimes you don't have to have those, but if you have a horizontal, then you don't have an oblique or vice versa. So in this case, we are gonna see the denominator and the numerator's degree. So the degree on the top, okay, this has a degree of 2. The degree on the bottom, if I were to put it in order, x plus 3 first, this has a degree of 1, okay? Based on your definition, the degree on the top is larger than the degree on the bottom. This gives you an oblique asymptote. So we're going to write oblique asymptote as OA. Okay, so we're going to start with the y equals. We're going to give it an equation, and then we'll fill it in. So that way I don't forget to write an answer. So in oblique asymptote, we're going to do long division. So here we go. Your denominator goes here, which is x plus 3. Your dividend, which is the numerator, is 5x squared. That goes here. You can technically write missing terms in at 0x and then plus a 0. I always try to do that anyway, so that way I don't forget. So 5x squared divided by x is going to give me a 5 in value. Okay. 5x. Give me 5x squared divided by x is 5x. Multiply that back. Okay. So 5x times x is 5x squared. 5x times 3 is a positive 15x. And remember, we have to go in and change all of the signs. So this is now a negative, and this is a negative. And we're going to combine these. The first two will always cancel. I now have a 0x and a negative 15x, so that's going to give me a negative 15x here. Bring down my 0. So the 0 is right here. I am invading this space a little bit. So negative 15x divided by x, that's going to give me a negative 15. So write a minus 15. Make sure you can see this minus sign here. Okay, so this is a minus 15. So negative 15 times x is a negative 15x. Negative 15 times 3 is a negative 45. We're going to go back in and change all of our signs, okay? So this is a plus, this is a plus. We can combine. When I combine that, this is my remainder of 45, okay? But what do we do with the remainder? We normally put it behind here, okay? So we're going to go, hey, that's a positive 45. So we'll write positive 45 over x plus 3, okay? So technically, this is our answer, okay, the quotient. But remember the limit as x approaches infinity. So as x approaches infinity, which is a really large number, what happens when you have 1 billion, 1 million plus 3? That's a really large number in the denominator. So 45 divided by a really large number, this remainder right here approaches 0, okay? So because it approaches 0, mathematician, we would like to say, hey, you know what? Since it approaches 0, we're going to assume that it's going to be 0. So we're just going to ignore the remainder. So when you're writing your oblique asymptote, you would only need to write these, the quotient, and not the remainder. Okay. So right now, your oblique asymptote, it's a line of 5x minus 15, and that's your oblique. Okay. So first, let's recap. Your VA, which is your denominator, because the denominator can never ever be 0, we're going to take the denominator, we set it equals to 0. So this is where we draw our vertical asymptote line. So the vertical asymptote line is at x equals to negative 3. Now, how do we know if it's oblique or horizontal? If it's oblique, that means the degree on the top has to be bigger than the degree on the bottom. The degree on the top is a power 2. The degree on the bottom, which is a degree, this x has a power of 1. Therefore, this is a degree of 1. Since it's bigger, we have to do long division. So now that we're doing long division, we have a line of y equals 5x minus 15. We always ignore remainder. Okay? Due to the fact that we are going to assume x approaches a really large number. Okay, so the limits of when x approaches a large number, this approaches 0. So if it approaches 0, it's not going to change this value very much. Okay? All right, so the second piece. Okay, I'm gonna separate myself here so that way I'm a little bit more neat. Okay, so let's move on to example B. Let's find the VA first. Okay, so first what we would like to do is try to see if we can factor this out. So f of x equals x minus 1. On the bottom, if I were to factor this out, it's x going to be plus 4 times x plus 1. As you can tell right now, none of it is canceled. We can't really cancel anything, so we're just going to find your VA. Your VA, we're going to take the denominator. We're going to have x equals and x equals, because I can see that I can have two answers here, so I'm going to box that up. Okay, so here's the work. X plus 4 times x plus 1 equals 0. This is where we're trying to look for values of x that would make the denominator 0. Okay, so separate those two. X plus 4 equals 0. X plus 1 equals 0. Subtract 4 from both sides, so x equals to negative 4. This is my first VA. This is subtract 1 from both sides, so this is going to be x equals to negative 1. So these are the two lines, okay, of asymptotes, vertical asymptotes. So x equals negative 4, x equals to negative 1. Now, let's check the degree of the numerator and the degree of the denominator. The degree of the numerator, because this is actually the first power. This is the degree of 1 on the numerator. This is x squared, so this has a degree of 2. Okay, so therefore, the degree on the top is not larger than the degree on the bottom. Hence, this is an HA, which is a horizontal asymptote. Horizontal asymptote and oblique. It's both gonna start with a y equals. So I'm gonna box that up. So that's where I'm gonna write my answer. Y equals to what? Now the horizontal asymptote, according to your previous video notes, okay, as the limit of x approaches infinity, then these right here would not change very much. Okay, so all we have to do is take the term on the top that has the highest degree. So the term on the top that has the highest degree is x. The term on the bottom that has the highest degree is x squared. Okay. So when we reduce, arrow, so x divided by x squared gives me 1 over x. Okay. Now as the limit of x approaches infinity, 1 over infinity is a really small number. It pretty much gives me a value of 0 because it approaches 0. So as the limit approaches infinity, your output, okay, so your output approaches 0. So right now, your horizontal asymptote is at y equals 0. Now we're going to do the last piece of example 1, which is, let me just draw some lines here so I can separate myself from the previous problem. Okay. And again, if this is going too fast for you, please hit a pause button, rewind it. That's the beautiful thing about video notes, okay? All right, g of x equals x to the third plus 3x plus 2 all over x squared minus 4. First thing I'm going to do is I'm going to try to see if it's factorable. Okay, so on the top, x plus 2 times x plus 1. On the bottom, this is the difference of two squares, so we're going to go x plus 2 times x minus 2. Okay. Now, if you look at this right here, I'm going to tell you right now, the domain right here is when x can never ever be negative 2 and x can never ever be positive 2, because when I put in negative 2, that would make the denominator 0. When I put in positive 2, it also makes it 0. So therefore, the domain is not including negative 2 and positive 2. Now, but it didn't really ask for the domain for this one. I'm just giving you that extra piece. But in terms of your VA, okay, before you can find your VA, you need to factor it out and then reduce. So if I were to reduce, I would now have g of x equals x plus 1 all over x minus 2. Okay. So this is my new reduced equation that I'm going to use to find my VA. To find my VA, which is an x equal equation, I'm going to box that up really quickly. I'm going to take my denominator, which is x minus 2. I'm going to set it equals to 0. Solve for x by adding 2 to both sides. X equals a positive 2. Therefore, I have one vertical asymptote at x equals positive 2. Now, let's check to see if I'm going to have an oblique asymptote or a horizontal asymptote. Okay? This is a degree of 1 on the numerator, because this is actually the first power. This is a degree of 1 again on the denominator. So the numerator is not greater. The degree of the numerator is not greater than the degree of the denominator. Therefore, this is a horizontal asymptote. Okay. So horizontal and or oblique, we're going to start out with the y equals. These are lines. Okay. So we need x equals or y equals. So horizontal is y equals. The work is we're going to take the term on the numerator with the highest degree. So y equals on the top, which is x to the first power, divided by, we're going to take one term on the bottom with the highest degree, which is now x. Okay, so they're both x's. So x divided by x is simply 1. Therefore, you have a horizontal asymptote at 1. Okay. Now, what do we have when we reduce, when x plus 2 will cancel out? This is now creating a hole. That's why Ms. Robinson defined the hole on the previous video. You do have a hole, okay? You have a hole at x plus 2 equals 0. X plus 2 equals 0. So if you were to solve for x, minus 2, x equals to negative 2. Now a hole is a point, so we're going to write in x at negative 2. Well, where is this particular y value? Okay, so what we need to do is we're going to substitute x in for your g of x. Okay, so your g of x is now x plus 1 all over x minus 2. Okay, I'm going to move up a little bit. Okay. Sorry, your hole is whatever you reduce or whatever was canceled out, you're going to set it equal to 0. You're going to solve for x, so therefore x equals to negative 2. Now, a hole is a point. Again, I'm just repeating what I said earlier because it wasn't moved up. So we're going to take the x value. This is your new input for your function. So now g of negative 2, which is negative 2 plus 1 all over negative 2 minus 2. Okay. We're going to combine the top and the bottom and divide. So g of negative 2 equals negative 1 on the top divided by negative 4. Therefore, this is a positive quarter. Okay. So your hole, you have a hole at -2, positive quarter. And you will always have a hole if it was reducible from the beginning. Okay, so that's what creates a hole, and that's why we define the definition of a hole. And again, if this is going too fast for us, please rewind, pause, and then that way you can understand it. Alrighty then, let's do example 2. Example 2 has 2 parts, okay? The direction for example 2 says, state the transformations, then we're going to need to graph each one. So we're going to first want to write this in order. So it's going to be f of x equals 1 over x plus 3. This is a rational function or equation here. So we're going to have a parent function first. Let's talk about the parent function. We're going to have it at f of x equals 1 over x. Now a parent function here has a vertical asymptote. When the only thing that we need to exclude from the denominator is 0, so your vertical asymptote is at 0. Your horizontal asymptote, I don't really have a choice on the numerator, okay, so I'm going to take 1 on the numerator, and I don't have a choice in the denominator, so I'm going to take x on the denominator. As x approaches infinity, your output approaches 0, okay, so even, let's just take 1,000. 1 divided by 1,000 is going to be a very, very small number, and 1 divided by 1,000,000 is even smaller. So the larger that x approaches, the output is going to be closer to 0. So your horizontal asymptote is at 0, and your vertical is also at 0. And this is always true for your parent function, okay? So now we're going to go in and graph both. A vertical asymptote, that means it goes up and down. If you have a pencil, do graph it out as dashed or dotted lines here for both. So that's your vertical. Label it as an x equals to 0. And label this right here as a y equals to 0. I'm going to make it as close to the x-axis as I can. So that's your y equals to 0 here. You have to sketch out your vertical and horizontal asymptote. Well, the next piece I'm going to have is I'm going to make my points here. My table of x. You are required to do minimum 3 points for each curve. Okay. So the first piece I'm going to pick out the point. The first set of points is the left side. Okay. So the left side of your vertical asymptote. So that means I'm going to pick -1. I'm going to pick a value of +10. I'm sorry, -10. What am I saying? On the left, and I'm going to pick a small value, -1 over 1/10. So this is the points. If I put -1 back into my parent function, okay, so which is, let me zoom it out really quick. When x is -1, so the input is -1. 1 divided by -1, my output is going to be -1. My input is -10, so 1 divided by -10 is going to be -1 over 10. 1 divided by -1/10. Okay, so let me show you this. So you have 1 divided by -1 over 10. When you guys are doing division, you're going to have to flip, right? So 1 times -10 over 1, which is now giving me a -10 as a value. So if you look at the trend, if you're dividing 1, okay, to any fraction, all you have to do, the trend is just to flip your fraction. So now your output is 10. So those are my 3 points. So let's plot it. -1, comma 1. -10, which is the last dot over here. My output is -1/10, which is very close to the asymptote. And when x is -1/10, which is very close to the vertical asymptote, my y value is +10. So here is my left curve. And you know what I just did? I just plot all the y values being positive. Ignore this. Okay. My dots are right. My plotting, it's horrendous. Okay, so let's just go and plot it right on the second time. -1, -1, so which is out on the bottom. Okay. -10, comma, -1/10. So -10 is an x value, -1/10 is on the bottom. -1/10, which is close to the vertical asymptote, and then go all the way down to -10 on the y. Alright, so this is the correct piece. So go ahead and erase the first piece that I did. Sorry. Your table is correct. My plotting was not so good. Okay. So that's the left curve. And if you remember, your rational function has two curves, the left curve and the right curve. So ignore this, okay? So now I'm going to plot the right curve. Right curve. Or right side. Doesn't matter how you say it. Alright, so input and output table. I'm going to choose some input value. So 1 and positive 10 and positive 1 over 10. Okay. So when your input is 1, 1 divided by 1 is 1. When your input is 10, 1 divided by 10 is 1/10. When your input is 1/10, and remember we just talked about it, when you are dividing a fraction, okay, with 1 as a numerator, you're just going to flip this. So now you have this as a 10. So we're going to have 1, 1, which is this piece, positive 10, 1/10, which is very close to your horizontal asymptote, 1/10, 10, that's going to be up here. So here is the second curve, which is the right curve. Okay. Alrighty then. So you have your left curve and your right curve. Okay. Now you only have one transformation, which is this positive 3, which you can't see right now. Here we go. You only have one transformation, which is a positive 3 right here. So we're going to write the next equation. Please write this down. 1 over x plus 3. This is a translation of up 3 units. Okay, translate up by 3 units. So what we're going to do, up is a change in y values. So all I have to do is find anything that has a y in it, and I'm going to add 3. Okay. So first, the vertical asymptote. This is an x equals, so I'm not going to change that at all. I'm just going to skip this because I'm out of space. I'm going to go over here, okay? So my vertical asymptote, graph that out, label that in, is not going to change by my translation of 3 units up. But my horizontal asymptote, I do have to move it up by 3 units, okay? So here you go, label it out, y equals 3. Now my points, the x values will stay exactly the same, but my y value, I'm just going to go and add 3 to it. So my left side, okay, my points are -1, which is the same. -1 plus 3 is positive. See, look at that, my basic math. And look, I can't even add. -1 plus 3 is going to be positive 2. And -10, that will stay the same because that's an x. -1/10 plus 3, it's a positive 2 and 9 over 10. And -1 over 10 is exactly the same. -10 add 3 is going to be a -7. So those are the points for the left side. So let's plot them. -1, comma, positive 2, which is up here. -1/10, comma, 2 and 9/10, that's very close to your horizontal asymptote, which is all the way up here. -1/10, comma, -7. So that's close to the vertical asymptote for the -1/10, and then we'll count 7 spots down. 1, 2, 3, 4, 5, 6, 7. Plot my dot. Alright, and that is the left. And we're going to do the same exact thing for the right. Okay. Right side. Okay, right side, when x is 1, that does not change because we have a translation up. 1 plus 3 is 4. 10, that's an x value, it doesn't change. But 1/10 plus 3 is 3 and a 10th. X value of 1 over 10. A y value of 10, 10 plus 3 is 13. Okay, so these are my right side points. Let's plot them up here. When x is 1, y is 4. When x is 10, y is 3 and a 10th, which is very close to your horizontal asymptote. When x is 1/10, it's quite small. Okay, so we're going to go close to the vertical asymptote, and we'll go up 13 units. This is a 10 by 10. So what I'm going to do is I'm going to add 3 more tick marks up above it and make it a 13. Okay. So those are my dots. And I'm just going to connect this. So let me just zoom out really quickly to get a better picture of what you were supposed to have. So parent function, all the normal points here. Then you have a translation of up 3 units. Therefore, only the y values change according to our order pairs here. So make sure you have your asymptotes graphed out, your asymptotes label, x equals and y equals. And this is the end of today's notes.